Here's more of a complicated Newton's law free body diagram problem where you have several different masses attached to each other. So we have a tractor trailer pulling two trailers, and it starts from rest and accelerates to a speed of 16.2 kilometers per hour. That takes 15 seconds, and it's on a straight, level section of the highway. So there's no angles that we're dealing with here. The mass of the truck itself is 5,450 kilograms. The mass of the first trailer is 31,500 kilograms, and the second is 19,600 kilograms. We're going to ask to solve for the magnitude of force that the truck must generate to accelerate the entire vehicle, and the magnitude of force that each trailer hitch withstands while the vehicle is accelerating. So we're going to assume that friction is negligible here, at least negligible compared to the forces that we're dealing with. So what does this actually look like in practice? So if you draw a quick sketch of what this really looks like before you get to the free body diagram kind of thing, um, you have your trailer B back here. That's attached to trailer A, and of course, that's attached to your truck. So you have your truck, and maybe it looks something like this. We're going to label the truck T. So we have T, and then A, and then B. What else do we know? Let's keep track of everything that we know for this question before we actually start doing some math. We know it starts from rest, so that means that V1 is equal to 0 meters per second. V2 is equal to 16.2 kilometers per hour, which is the same as saying 4.5 meters per second. We have our total time it takes, so that's 15 seconds. We also know a couple of masses. So the mass of the truck, 5,450 kilograms. The mass of A, 31500 kilograms. And the mass of B, 19600 kilograms. We're looking for the force required by the truck, force of A, and the force of B. Lastly, our free body diagram will kind of look something like this, and we'll do a little bit of a shorthand version just because there's a lot of forces happening here. So on trailer B, we have the force of A acting on B. On trailer A, we have the force of B on A, as well as the force of T on A. And then at the actual truck, we are going to have the force of A on T, and then just the force that the truck uses to actually move itself. This whole system could actually just be summarized by saying MT plus MA plus MB, and then having the force of the truck required to move everything. Now that we have all that relevant information from the previous slide, we can start to do a little bit of math here. So first and foremost, I want to solve for the force that the truck generates. So Ft, which is the force that the truck generates, is going to be equal to the total mass, so the mass of the system, times the acceleration of the truck. So we know the mass of the system. We showed it in the previous slide. That's just the mt plus ma plus mb. So that's 5,450 kilograms plus 31500 kilograms plus 19600 kilograms. And we also know the acceleration that this truck is undergoing. We can solve that. I'm going to do that off to the side here. So we're going to take a second, and we know that the acceleration is just a change in velocity over time. So that is going to be 4.5 meters per second. Since that's our V2 and there is no V1. And the change in time here is 15 seconds. So that gives us an acceleration of 0.3 meters per second squared in the forward direction. So that's the value that we're going to substitute in here for A. So we have our total sum of the mass 56550 kilograms times the acceleration, which we just solved for, 0.3 meters per second squared. Keep in mind that the direction is forward because obviously our force here is a vector. So that's going to be 16,965 newtons forward. Next up, we're going to solve for the force acting on B. So the FB, or F net, on B, which is the second trailer, or the one furthest away. If you remember from our free body diagrams, that was just the force of A on B. So how do we determine that? Well, the force of A on B is just going to be the mass of B times our acceleration. So the mass of B, 19,600 kilograms, times our acceleration, we calculated on the previous slide, 0.3. And that's going to leave us with 5,880 newtons. So that what that means is therefore the force that the second hitch must withstand is 5,880 newtons. Lastly, we're going to look for the force on A. So F net of A, which is just similarly the mass of A times the acceleration on A. Now this one's a little bit more complicated because F net A is going to be equal to, so we'll say MA A. This one's going to be equal to the force of T on A minus the force of B on A. And go back and take a look at the free body diagram if you're unsure where those two components are coming from. So there's quite a bit here to digest. We're ultimately looking for Ft on A, and that's going to help us figure out the force that the first hitch must withstand. So that's the force of the truck pulling A, and then subsequently B. Because we know a lot of this stuff here. We know Ma, so the mass on A is 31,500 kilograms. The acceleration is going to be the same as it is everywhere else. We don't know Ft on A, but we do know Fb on A, right? It's just going to be the opposite, which is why we have this negative sign of the one we just solved previously, 5,880 newtons. So we can rearrange this and we end up solving for Ft on A. And we get a value of 15,330 newtons. So that's the force required that's going to pull A, the force of the truck on A. So we can actually just do a quick check to see if this is true. Everything we've solved for, there is a nice way to just see if kind of these numbers make sense. What you can do to check is just make sure that Ft is greater than Fa is greater than Fb, which for us it is, so we can be relatively confident in our answer.